BioGeoChemical sedimentary rocks are kind of just a bunch of miscellaneous rocks that happen to form near the surface of the Earth that are not made up of other rocks. It's kind of a mishmash category. So what do we have? We have geochemical rocks that form when mineral-rich pools of standing water evaporate and those minerals stick together. And biogeochemical rocks are made of the remains of life, plants and animals. Now, most of the biogeochemical rocks are limestone, so let's start there. Limestone is made of calcite or calcium carbonate, depending on whether you're talking about a geochemical rock that formed from the mineral calcite or a biogeochemical rock that formed from the calcium carbonate shells of animals. Tomato, tomato. Anyway, when we talk about limestone, we are either talking about biogenic, that biogeo stuff, or calcite limestone. Now, calcite limestone forms when there's a lot of dissolved calcite in groundwater. Solid calcite breaks down into ions pretty easily in water. In fact, most rainwater can do it. But when the water either boils off from a hydrothermal spring, like in the case of travertine, or when groundwater drips through the cave systems or evaporates, like with crystalline and limestone and microcrystalline limestone, voila, you get limestone. Now, as I mentioned, animals can also make their shells out of calcium carbonate. Oysters, clams, snails, and microscopic life like coccolithophores, which make up chalk. I bet you didn't know that you were drawing with the ground-up bones of microscopic life whenever you use chalk. That's pretty metal, right? Some things I studied in grad school, foraminifera, make calcium carbonate shells too. So limestone is near and dear to my heart. There are a few different classifications of biogenic limestone. Coquina is completely made up of shells that have fused together, but they are still very recognizable as shells. Fossiliferous limestone has shells in it too, but there are much less, and they are encased in microcrystalline limestones. Chalk is that tiny microscopic shells fused together that we talked about before. But limestone isn't the only name in the game, right? There's quartz, gypsum, halite, and carbon, which can also form rocks at the surface of the Earth. These are by and large not organic, and they're formed when mineral-rich water evaporates or is pressed out of the mineral, which then congregates together and fuses. Now, this isn't like a single mineral grown out of a melt. This is a bunch of minerals that all sort of glom together into a rock. Chert is the rock form of quartz, and it's really useful. It can petrify a tree, leaving a cool fossil behind, or it can be used to make really sharp and hard things like arrowheads and knives. Rock gypsum and rock salt form when a large briny body of water evaporates. Think like the Great Salt Lake in Utah. Now, I don't want to get too far in the weeds on this one, but coal is actually a biogenic rock. Coal is the fossil of a swamp. Cool, right? So, peat forms when all of those swamp plants die and get buried in the mud, and that mud compacts into a really loosely formed soil called peat. Then, as it keeps getting buried, it compacts, and it becomes lignite. Further compaction gets us bituminous coal. And if there's some crazy pressure that compresses the coal even further, it's the highest grade of coal called anthracite. As the coal gets compacted, more and more of the stuff that isn't carbon gets sort of squished out. So anthracite is the most pure coal, the most pure carbon. And in the biz, we call that carbon clean coal. Now, clean coal releases just as much carbon into the atmosphere as any other grade of coal. It just has less other junk in it than other grades of coal. It's not a green energy source. And there you have it.